Astronomers have detected thousands of worlds beyond our solar system, but despite decades of searching, we have never detected their magnetic fields. Today, we might have found the first clue. Hello, I'm Dr. Jake Turner. So in this study, we found the first hints of radio emission coming from a planet outside our solar system, a giant planet called Tau Boötes b. We've known from our solar system that planets with magnetic fields, such as Jupiter, naturally emit radio waves. And what is going on is basically particles from the sun, electrons and protons, when they get caught in the magnetic field, they gyrate around the magnetic field lines and they create light. And in the case of the planets, this light is in the radio. Same electrons that create the radio emission continue down and actually hit the atmosphere to create the beautiful auroras that we see. We were able to actually discover that Earth had radio emission after we started sending satellites into space. Shortly after that, when we sent the Voyager probes, we were able to discover radio emission from Saturn, Uranus, and Neptune. So it wasn't until we discovered the first hot Jupiter in 1995 that we started realizing that maybe these planets would be better to search for a radio mission. These planets are orbiting really close to their stars. They're orbiting at about a day or two. Because of that, they're getting bombarded by a lot of electrons from the solar wind. The more electrons you have that are hitting the magnetospheres of the planets, the more radio light you will get. And this target turned out to be one of the best for that because it's really close to its host star. It's also a really massive planet, a lot more massive than Jupiter. So people have definitely been thinking about this system for a while. So the telescope we use is called LOFAR. It's the low frequency array. Parts of the telescope are located all across Europe, but we only use the core of the telescope in the Netherlands. And this is a state-of-the-art telescope, and it's one of the most sensitive low frequency telescopes we know. So assuming the radio emission is real and coming from the planet, the first thing it tells us is that the planet has a magnetic field. When we first discovered the radio emission from Jupiter, we were actually able to figure out what was going on in the interior of Jupiter. There has to be some kind of metal that is creating the magnetic field in the first place. In the case of Earth, that's iron liquid core. In the case of Jupiter, that is metallic hydrogen. Our study using LOFAR to learn about the magnetic fields of Jupiter-like planets is just the first step on the ladder. I'm excited that in the future we will have a radio array, perhaps on the moon, that can be used to study the magnetic fields of Earth-like planets around other stars.